Today we'll be doing the integral from 0 to pi over 2 of the natural log of the secant of x divided by the tangent of x dx. And to start off, we will rewrite this integral as the integral from 0 to pi over 2 of the cotangent of x times the natural log of the secant of x dx. And we will use integration by parts. So we'll let u equal the natural log of the secant of x, which means that du equals tangent of x, and dv equals cotangent of x, so that v equals the integral of the cotangent, which is the natural log of the sine of x. So this is equal to the natural log of the secant of x times the natural log of the sine of x from 0 to pi over 2 minus the integral from 0 to pi over 2 of the natural log of the sine of x times the tangent of x dx. And as x approaches 0 and x approaches pi over 2, this will go to 0, and we're left with negative the integral from 0 to pi over 2 of the tangent of x times the natural log of the sine of x dx. So with integration by parts, we have their integral is negative the integral from 0 to pi over 2 of the tangent of x times the natural log of the sine of x dx. And from here, we will rewrite this integral once again is equal to negative the integral from 0 to pi over 2 of sine of x over the cosine of x, natural log of the sine of x dx. And then from here, I will multiply the numerator and denominator by a factor of cosine. So I have a cosine of x over the cosine of x. And this is equal to negative the integral from 0 to pi over 2 of sine of x cosine x ln of sine of x divided by the cosine squared x dx, which is equal to negative the integral from 0 to pi over 2 sine x cosine x log of sine of x divided by cosine squared can be represented as 1 minus the sine squared of x dx. And from here we could use a substitution. So I'll let r equal the sine of x, which means that dr is cosine x dx. R sub 1 will be the sine of 0, which is 0, and the sine of pi over 2 is 1. So we'll have a negative the integral from 0 to 1 of r natural log of r over 1 minus r squared, and this cosine x dx term will become a dr. And then once again, we'll use another substitution. So I'll let s equal 1 minus r squared, which means that s minus 1 equals negative r squared, which also means that 1 minus s equals r squared. And solving for r, we have r equals the square root of 1 minus s. And we'll have that ds over negative 2r will be our new dr. And the bounds of integration, s sub 1 will be 1, and s sub 2 will be 0. So s is going to go from 1 to 0. So we have negative the integral from 1 to 0 of r log of square root of 1 minus s divided by s, and dr is ds over negative 2r. And as you can see, these r's cancel. We could bring down the 1/2. So you have negative times negative 1/2, the integral from 1 to 0, the natural log of the square root of 1 minus s over s ds. And then this negative sign I will use to flip the bounds of the integration. So I'm going to have a negative 1/2, the integral from 0 to 1, natural log of the square root of 1 minus s over s ds, but the natural log of the square root of 1 minus s. With logarithm rules, we have 1/2 the natural log of 1 minus s. So this integral becomes -1/2, the integral from 0 to 1, 1/2 log of 1 minus s over s ds. Combine the 1/2s, we have -1/4, the integral from 0 to 1, the natural log of 1 minus s over s ds. And from here we'll use the power series representation of the log of 1 plus x. So the log of 1 plus x is the sum from 1 to infinity, -1 to the k minus 1, x to the k over k. But we're interested in the case when x equals -s. So the natural log of 1 minus s will be the sum from 1 to infinity, -1 to the k minus 1, -s to the k over k, which means that the natural log of 1 minus s equals the sum from 1 to infinity, and -1 to the k minus 1, we can rewrite it as -1 to the k times -1, and -s to the k, we can rewrite it as -1 to the k s to the k over k. And these -1 to the k's will end up being a 1, and we'll have a negative the sum from 1 to infinity of s to the k over k. So we'll implement that into our integrand. This is equal to -1/4 integral from 0 to 1, 1 over s, times negative the sum from 1 to infinity, s to the k over k ds. And as you can see, these negatives will cancel, and we can exchange the sum and integral. So we have a 1/4 the sum from 1 to infinity of 1 over k, the integral from 0 to 1 of s to the k over s ds, which is equal to 1/4 the sum from 1 to infinity, 1 over k, the integral from 0 to 1, s to the k minus 1 ds, and the integral from 0 to 1 of s to the k minus 1 will be s to the k over k from 0 to 1, which is equal to 1 over k. So we have 1/4 the sum from 1 to infinity of 1 over k squared, which is equal to 1/4 zeta 2, which is 1/4 times pi squared over 6. In other words, pi squared over 24. And that is the final result. Thank you very much for watching.